Okay, I'm going to tackle 6J here. So let's see. Let me get some paper handy here. It's not enough to write on. Like writing on a nice smooth surface. 6J is y equals 2x plus 3 to the 3 all over the square root of 4x minus 7. Okay, so step one is let's turn that into something more differentiable. 4x minus 7 to the 1/2. And I'll leave it down there in the denominator and use the quotient rule. And of course, with the quotient rule, you're going to end up using chain rule. So y prime, you got to give myself a lot of room. This one's going to be long. Quotient rule is it's the denominator times the derivative of the numerator, and I need chain rule for that. So 3 times the bracket minus 1 on the exponent times the derivative of what's in the bracket minus. So the derivative of the denominator, which is 1/2, leave what's in the bracket alone, minus 1, times the derivative of what's in the bracket, times the numerator, all over the denominator squared. Finally, one thing that's actually easy. When you square something that's square rooted, you just get itself. Okay, so that is what you should have, and the picture that you sent me, I noticed you had this, but I don't think you had all of that. I think you were missing that, unless you tried somehow to combine this down there with that, which is why I saw that 3/2 on the exponent down here. But you can't just move this to the denominator without dealing with that. At least not directly, unless maybe there's a couple steps here that we can do. Okay, what do I want to do with this? What do I want to do with it? And what am I going to do with it? Those might not be the same thing. All right, I think I might actually... well, first of all, let's multiply some... Let's do some math here. That cancels, so that's a 2. And then I can factor out a 2. So I'm going to just factor out a 2. I can factor out a 2x plus 3 squared. And that's going to leave the 4x minus 7. Yeah, we might actually factor out that too, but I'm just going to try this for now. To the 1/2. There's still a 3 here, okay, because I factored out the 2, but the 3 still left behind. Minus 4x minus 7 to the negative 1/2. And there's still a 2x plus 3 factor, because this was a 3 and I only factored out 2 of them. All over 4x minus 7. Okay, now what? Well, let's turn that into the denominator it belongs to be. So 2 times 2x plus 3 all squared. And this part here is sheer numerator. 3 times 4x minus 7 to the 1/2. But this part here is definitely denominator, so I'm going to call that minus 2x plus 3 all over the square root, so 4x minus 7 to the 1/2, and all over 4x minus 7. Okay, now from here, if I actually get this as a common denominator, remember this is over 1, I'm going to times the top and the bottom of this by 4x minus 7 to the 1/2, which actually is going to simplify a bit, because now I have 4x minus 7 to the 1/2 times 4x to the minus 7 to the 1/2, which is actually 4x minus 7. Minus 2x plus 3, which is 2x minus 3, all over 4x minus 7 to the 1/2, all over 4x minus 7. I'm starting to see where you got that 3/2 from. Okay, so from here, I am now going to do some simplification up there. So that's 12x minus 2x, so 10x. Negative 21 minus 3 is negative 24. All over 4x minus 7 to the 1/2. And instead of dividing by this 4x minus 7, I'm going to times by the reciprocal of 4x minus 7. And that's where you got that 3/2 from, because you added 1/2 and 1. Oh, okay, I see that now. And then final answer, I could do some more factoring. 10 and 24 have a common factor of 2, so I can take another 2 out, combine it with this 2 and get a 4. And then 2x plus 3 all squared. And then there's a 5x minus 12 here. And on the very bottom, I am left with 4x minus 7 to the 3 halves. And I think I'm going to stop there and check and see if that's their answer or anything close to it. So let's see. This is, what is this? 6j. So 2.6, 6j, and I think I have it almost exactly. Yeah. 5x minus 12, and they left it as a rational exponent of 3 halves. So yep, we got it. We got it exactly. Ta-da! So that's how you do that one.